All right, now we're going to take a look at doing a stoichiometry problem. All right, so hopefully you watched the first video or a group of videos that I didn't even do on mole ratio and what that is. That'll be important. But what we're going to do now is take kind of a simplified version of a question, but really all questions come down to the same thing. What are you starting with? What are you trying to find? If you know those two things, you got it, right? And so the question that I'm proposing is how many grams of Na2SO4 are needed to, all right, and we're going to do two separate questions. What we're starting with is chemical equation. If you watch the last one, then you already know what this is, but you can never do stoichiometry without a balanced chemical equation, right? So if I give you just, an equation, I ask you to balance it, you have to do that. If you just give me all one-to-one ratios, more than likely you're not going to come up with the right answer. We need these numbers. So you know how to do this, but either way, we should have a 3 there. We should have a 2 there. We should have, you might want to put a 1 there, even though we don't technically need it. So you remember that there's a 1 there and a 2 there. All right. So we're going to start every problem that way. So maybe that's part of the problem. Maybe it's something that I've already given you. Either way, we want to do it. All right. So I'm going to go down. I'm going to take a look at this guy. So I want to produce. So I'm trying to get, for this question, I'm trying to get to Na2SO4. Okay. I'm trying to produce 5.25 moles of Na3PO4. Okay, so I need my balanced chemical equation. I'm going to rewrite it down here, even though technically we probably wouldn't do this. Now, if you've gone through the ChemQuest and you've read some things, I call this the mole through the hole. Okay, and here's how I want to take a look at it. There's 3 steps. Not every problem needs 3 steps, but there's 3 steps every problem. We start with what we have, right? So how many grams? That is Na2SO4. So I'm going to write a question mark right there. Okay. And what I'm going to start with is, all right, I have 5.2 moles of Na3PO4. Okay. So Na3PO4 is right here. Now, one thing I'm going to show you as I do this is I'm going to draw in different colors, different lines. All right. So I'm going to draw this. And then I'm going to come over. There's a green line. Here is a red line. And then we'll do our blue line because we're going to go to our blue question mark. All right. So stoichiometry problems kind of set up this way. And what those arrows are, those are the possible ratios that we could use. Okay. So I'm going to write some more stuff in. The points of these, if I have grams, I'm up here. Then I get down to my mole level right here. And I'll explain that in a second. And I come over to my mole level right here. And then I go up to my gram level right here. Now, the way this is worked out, and if you read through the ChemQuest, I think of this as the little furry creature, a mole. Right? So if this top, if this is like, I got my trees going on, moles are above ground every once in a while, but they want to get away from predators. So what they do, they can't just scurry across the ground. They'll die, right? My tires, my dog, my cat, whatever. Those moles are not very quick. They can't see very well. They're not going to last very long if all they do is scurry across the ground. So the meaning of that is I cannot go directly from grams of one substance to grams of another. You cannot scurry. You cannot be a mole and scurry across the ground. You got to dig holes and you got to dig tunnels, right? And so I got to go from grams to moles to moles, moles to grams in some instances. So for this one, what I'm going to write down is I'm going to write where I'm at. So I know I have 5.2 moles of Na3PO4. So I'm going to write that right here. I have 5.25 moles. I'm going to write it right under that guy. So the meaning of this is I don't need that ratio. Okay, I don't need to go from grams to moles. I'm already at moles. That's perfect. That's our point of comparison if you watch the last video. So my steps are, I haven't really done any math. I need to go from moles of this to moles of that, and from moles of that to grams of that. Okay, and we can do it. So just like normal, you don't have to draw the pictures. For some of you, it'll be a very good idea, right? It'll be a very good idea to draw the pictures because then you'll have this idea of the flow of this guy. All right, but anyways, I'm going to start with what I know because that's how we start every problem. So I'm going to start with 5.25 moles, right? of Na3PO4. It is very important, just like always, that you have all three of those steps. So for those of you that have been practicing that, this shouldn't seem that much different. All right, so now I'm going to use my red because that's actually my next step. That's my next arrow. So that's just that 5.25 is what I know. My next step is to go from moles of one thing to moles of another. So it's just kind of a visual to watch that happen. But either way, you've done dimensional analysis long enough. You know that what we don't want goes on the bottom and what we want goes on the top. And so this is from the last video, this is our mole to mole step. Again, this is the absolute only step you can ever use to go from one type of a substance to another type of a substance. If you put any other units here, you're wrong. Okay, the mole to mole ratio, that mole to mole step, getting this mole down here to dig his tunnel, that's the only way we can do it. Once you realize that, it's pretty simple. We just use the numbers that are given to us in the balanced chemical equation. We put them in there. And if we look, oh, look at that. That cancels out. Been there, done that, right? The last step, because I only have two lines, is going to be this. I'm going to put my moles of Na2SO4. I'm going to go up to my grams. So I'm going to put grams of Na2SO4. Really important. Do not, I repeat, do not put that 3 back down here. The balanced chemical equation is only for the mole to mole step. Okay, we've done this step before. This is called the molar mass. Grams, moles, moles, grams. We know what to do. That's always 1 mole for ever how many grams we calculated on the periodic table. And for this one, that is 142.1. Okay, cross out. Biggest thing is, did we solve for what we wanted to? The main question was, how many grams of Na2SO4 do we need? Okay, that's exactly what we found. So I'm going to type it in so we can see it. So we have 5.25 times 3 divided by 2 times 142.1. Okay, using the correct number of sig figs, I should get an answer of 1120 grams Na2SO4. There we go. That's showing our work. Now, let's take it one step further. Let's go down here to this problem. Again, we're going to put our question mark right there. Different question, ending up with the same results. Okay, so I can write this one backwards. There's my arrow. I'm trying to get there. Where am I starting? Oh, this case I'm starting with, I completely react 25 grams of AlPO4. So my 25 grams of AlPO4 is right there. Okay, so I can go down to my moles, right? Using the same color combination, I can go over to moles of that, and then I can go up to my grams of Na2SO4. Again, you do not have to write those. If you understand the math, great. If you're struggling, lots of times these little steps, just drawing a picture helps out a ton. All right, so let's just do the math now. All right, so we're going to start with what we know. I know that I have 25.0 grams of AlPO4. Okay, I'm right here. I need to go down. So that's going to look like this. Change colors. This is kind of new from our first one. We start with what we know. We go to where we have to. So I know I have grams of AlPO4 down here. And just like always, this is where the picture helps. But if you remember some of the other things I've said, every single time in this unit, we have to have moles as part of our ratio. So automatically, if we have grams on the bottom, we know moles has to go on top. And since this is grams to moles, this is still moles of that same guy, moles of AlPO4. No, so for every one of those, we look it up on the periodic table, and we see that that's 122.0 grams. Great. Grams of AlPO4 is gone. Now I'm right here. I got to move across. I got to go to my moles of, right? So I'm going to change colors. Put my moles of AlPO4 on the bottom. Okay, and I'm going to put my moles, so here's my mole to mole ratio of my Na2SO4 on top. Again, the only time we can change the compound is at this step. right? That's why it's very important that you show me this every single time. So looking, maybe I should have wrote those in so I don't forget, right? At this point, I have a 2 on the bottom and I got a 3 on top. Great. Now I'm right here. Now I got to take my last step in this problem. PO4 is gone. Take my last step, and that is putting moles of Na2SO4 there and putting grams of Na2SO4 on top, right? Again, mole ratio, do not put a 3 here. This is a 1, right? The numbers over here are for mole ratio. This is molar mass, grams and moles. This comes from the periodic table. So it's 1 for every, look it up, add it up. Oh, same as before. So I have my 142.1. Moles cancel. We're done, right? We are left with grams of Na2SO4. So let's put that in our calculator and see what we come up with. Okay, so I have 25.0 divided by 122 times 3 divided by 2 times 142.1. Again, it might not look the same in your calculator if you're using actual fractions. That's totally okay. But using I gave you 3 sig figs. I should use 3 sig figs. So if you look at my number, it's 43.678. So I should be writing down 43.7 grams of Na2SO4. Okay, so there's a couple quick Stoic problems for you to take a look at as you're doing it, before, after, during, you get stuck. Again, not a bad idea to write down these little arrows, and we can go from a product to a reactant. We can do both reactants. We could do both products. We could go from a reactant to a product. It doesn't matter. Wherever you start, you can end. The main difference is we can do that because of this mole to mole step, this mole ratio step. So don't forget it. Know when to use it.